So I just want to show you something. I'm going to enter some data. You can say first of all, to have names. Grades. Okay, so we can have total. So when I total these for one student, I use the auto sum. This is the total. Use the same. Okay. Then I need to find the maximum. Maximum, minimum, then average. So we'll find the average. I'll show you this later, but it's not supposed to. It's not that important to you, but you just have to know that when I want to find the maximum for the students who are the maximum grades in a certain subject in Excel, I have to type equal sign, then type max, then open bracket. Then I'm going to enter the cells. This 67 is in C4, so you type C4 to C4 to C5, C5. Then you close the bracket, you enter. So the maximum is 67. You need to calculate, even if you can see that is 67, let the Excel calculate. All you have to do is enter the formula. You need to know the formula. So we are finding the minimum, open bracket, C4, full colon, C5. Okay. Then the average, you do the same, start with the equal sign. You type average, open bracket, do the same cells. Let's say average. You can also find the for everyone. You can also find the for everyone. You can also use the you can also use shortcut. Okay, as you can see, I'm using the auto sum. 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 Then I'm looking for the minimum. Okay. I'm looking for the average. Yes. And this one maximum. Maximum. Minimum. Minimum. Average. Maximum. Okay. Maximum. Are you able to do what I'm doing?
Yes.
Okay. This is a mistake. I'm looking for minimum. So just type the minimum. The average. Okay. So the whole idea of doing this is to conclude this data in a chart. In a chart. Okay. So you can select everything, highlight everything, then go to insert. You go to insert, then you look for the charts. Charts are there. Charts are there. You can look for a 3D if you want. Let me just look for other. For me, I'll use the what am I going to use? I'm going to use you can use the same chart. Have you seen?
Yes.
We have Patrick in blue, in light blue actually. So when you look at this chart, you can tell that this Patrick had so many marks, but you can do a pie chart in the sense that we include the data labels. This is right. Have you seen?
Yes.
Yeah, 67, 45, just like that. Okay. So this, if you want, you don't need data. All you need is a pie chart. You present data using just a pie chart. People are not supposed to see the figures and so on. They'll be bored. So it's enough for you to just show them their percentage. That's it. Okay. Okay, so this is how you can come up with that. Then there are also bar charts. If you paid attention on where I was getting those charts, there are types of charts, including the bar charts also. So whether we show the proposition for 1 year or 10 years, we obtain the same chart. The propositions or the relative frequencies don't change with the number of values. Let's say, look, we have 1 year, we have 10 years, it's all looking the same. Then relative frequencies, when the bars in a bar chart represent the number of items in each range, we call it histogram. So these bars we have, 1 year got 3 bars, 10 years got 3 bars. So these bars are called histogram. They're the ones which are called histograms. So a bar chart shows values of a quality histogram. A histogram shows the relative frequency of values of a quantity. Relative frequencies are useful for representing data that changes with each measurement. Relative frequencies are useful for representing data that changes with each measurement. And let's look at the measurement. Any measurement is affected by many factors. Any measurement is affected by many factors. If we use a ruler to measure a piece of string, the result will depend on how much we stretch the string, isn't it?
Yes.
How much we stretch the string. So maybe you can stretch it. Another one cannot stretch it so much, so the measurement will differ. So when you're measuring something, it depends on how you stretch it. Whether we look at the marking on the ruler from any angle, whether the string is wet, whether the string is wet or dry, whether the string is wet or dry, whether the string is wet or dry, how good our eyesight is, where we hold the ends of the string also matters. When you are measuring, so this is where you find that you tell someone to give you the measurement. Let's say you want to make something very important and someone else goes and get the measurement. It's possible, 100% possible, that other people can give you wrong measurements, okay? Other people can give you wrong measurements. Others will give you the correct measurements. Then the same measurement gives a different result when it is repeated. The same measurement gives a different result when it is repeated. Okay, we cannot predict this variation, so we call it a random. We call it a random. The net effect of many random variation, we call them noise. They are called the noise. I remember this skills for computing. Most of the questions when they come in the exam room, they concentrate more, starting actually from topic 7, 8, 9, 10, up to 12. They like, these topics are very much examinable. Those topics can come, topic 1 up to 6 can come, but not that much. A lot of questions, they come from these topics, especially not starting from topic 8 until topic 12. They like bringing questions from there. So this is where we have a lot of statistics. Skills for computing, it's about, most of the time, it's about statistics. So distribution. In distribution, we cannot predict randomly. We cannot predict randomly. We cannot predict randomly varying values, but we can measure how often they fall within a given range. So this process is called the binning. The process is called the binning. This is done by separating the range of samples into smaller ranges. These smaller ranges are called bins, the bin, and count how many values fall into each bin. It's very easy to see the relative frequency of values in each range, These are the distribution. By the way, this is the statistics. This is part of statistics where we have a distribution. You have to know what a distribution is all about. If we have many values, we can make the bins more narrow and get a smoother curve. The histogram represents data from a large number of measurements, As the number of measurements increases, it begins to look like a distribution. Mwamba.
Yes, sir. Can you see me?
Yes, how are you?
I'm all right, sir. Sorry. My network was down. Okay,
actually, what you should do for the network to be better, yes, because
okay.
When your video is on,
Okay.
it chews a lot of bandwidth. So just turn it off. You remain with the voice.
Okay. The voice. Okay. So the video is off right now. I'm just going with the voice.
No, now I'm able to see something. I'm able to see you.
Okay.
Just turn on
but
me.
I can't see.
Yeah, for me, you can't see me. Just on the video,
Yeah.
just click on the video. Just cross it out. Click on the where it says the start video, where there's a video. When you click on it,
okay, it's off.
So like this, it's better. When the video is on, it chooses a lot of bandwidth.
Okay, carry on.
All right, okay. So we are talking about the distributions. By the way, we are still using a free version of Zoom. And this free version of Zoom, after 40 minutes, it will time out. So you just have to log in again within seconds. Yes. So we are talking about distributions in statistics. This course you are doing, it's based on the statistics, maths and statistics. So we are talking about distribution. Look at these two distributions, these two diagrams we have. The distributions they represent the number of the histogram that we talked about. Let me take you to this slide. This slide that shows the histogram, or basically a bar chart. When I draw a line starting from the left corner, the left corner, the below one, start following these diagrams, I'll come up with more like an complete curve. I'll come up with a complete curve. Then if you can have more bars, start coming down like these two we have, then we can have a curve. It will look more like a proper hue. Then it will show us a distribution like what we have here, like what we have there. These two diagrams we have. So if we have main values, we can make the bins more narrow and get a smoother curve. Then histogram represents data from a large. Histogram, it's these bars we have, these 3 bars we have in 1 year, 3 bars, in 10 years, 3 bars. So each bar, it's called histogram, actually, histogram. Then in this chart, we call it a bar chart. Histograms are found in a bar chart. Histograms are found in a bar chart. Okay. So the histogram represents data from a large number of measurements. As the number of measurements increases, it begins to look like a distribution. So this type of curve you have, it's a one which is called a distribution. A distribution shows how often we obtain data close to some value. A distribution tells us how values vary. By the way, values can vary. Values, they are different, they're not the same. It does not tell us what the values are. We talked about the measurements. If you want to get the values of, let's say you are measuring something, depending on, let's say if I'm measuring maybe something, depending on how stretched it will be, the measurement will be different. Or if I repeat the measurements, don't be surprised that you can still get the different measurements, but from the same. Let's say I took the measurement this season, this cold season, and I come and take the measurements in October. You have to know that things in October starts expanding. They do expand. So you find that the measurements will be different from what you got last time. I'm sure you've noticed that some doors, even in the house, some doors this season, they might be fitting nicely. Then when they start expanding, the same door which was fitting, it couldn't fit because it has expanded. Then let's look at the normal distribution. Measurements are affected by many factors, some which partially cancel. The net result is what we generally get values with a small error, more often than values with a large error. The corresponding distribution is shaped like a hue, also sometimes called a bell-shaped. That diagram below, when you look at that diagram below, that shape below, it's looking like something with it has got a belly, or it's looking something like a hue. So the main examples of this code, when you find this type of distribution, call it a normal distribution. A normal distribution, which has got a bell-shaped. It has got a bell-shaped, or okay, just a minute. Or we can call it the normal distribution. It's different from this distribution we had. This distribution are too stiff. Then the other one is straight. So let's call it a normal distribution. A normal distribution. Then the normal distribution is important because it occurs very often in practice. It occurs very often in practice. We are going to know why this normal distribution occurs very often in practice very soon. By the way, those who, I know Mwamba also missed the first classes we used to have. At this level, you only have theory exam in skills for computing. This course you are doing skills for computing. This is where you have exam and the assignment. Then computer systems, things have changed there. You are supposed to do the exam and assignment, but they have put assignment 100%. So you have to work on the assignment. That will give you 100 marks. You have to do it perfectly. Then computer networks, you know, computer networks is 100% assignment also. Then you just have actually two exams, two written exams, SDT and the skills for computing, SDT and skills for computing. So since now the assignment is 100%, I want all of you to send me what you have done so far. To send me what you have done so far. I want to start checking task by task. It doesn't mean that we have to meet as a class, then start. This one will be actually one-to-one. I want to see one-on-one. I want to see you individually. I'll start with Mwamba. I'll find a day where I can meet Mwamba. Then I'll go to another student, just like that. You have to do it. You don't have where to get, you only have one source of getting marks, meaning that assignment. In this course you are doing, you can get marks from exam, you can get marks from the coursework as well. But in computer systems, you only have assignment. You don't have to write what won't be, it has to, what you write needs to attract the markers. I know I do mark, but I'm not the only one who marks. We have people from the, I'll do the first marking. We have people from the UK are going to mark, and other external examiners as well. So for me, I can give you 100% if I want, but you find that this one person will come and just try to play with the marks, so that we don't want. So I said the normal distribution is important because it occurs very often in practice. So we get values from the central region more often. We can see this information, I mean this from the fact that the height of the distribution, which shows the relative frequency, is greater near the center, is greater near the center. So when you look at this diagram, the center is just unfortunately you can't see me, but you know where the center is for this distribution. The center is just right there where there is a berry shaped like, that's where the center is. Then the extreme left and right of the distribution called tails represent values which occurs rarely. Our session is about to time out. We are remaining with 1 minute 40 seconds, but just log in within seconds. Just log in within seconds. Central value. We can summarize a collection of values with one number called central value. Central value. Just we'll look at some numbers, then I'll show you what a central value will look like. So this gives us a typical value for distribution in the sense that most of the measurements are usually not far from the central value. It gives us typical values for the distribution in the sense that most of the measurements are usually not far from the central value, usually not far from the central value. So we have a normal distribution, we've got central value, then there's a median. What is the other word for the median? For the median. What's the other word for the median?
Yeah.
Remember we did this. It's like we are doing what we did. So you should know what a median is. A median.
So square between
The median, it's a middle number. Middle number.